All right, so we have the nth partial sum, S sub n, of some series where the terms are a sub n's, is 3 to the n minus 9 over 3 to the n plus 1. And we're supposed to find the exact value of the sum of the terms. Well, remember, the sum from n equals 1 to infinity of a series where the terms are a sub n is the limit as n goes to infinity of the partial sums. You just take more and more partial sums with more and more terms, let the number of terms go to infinity, and you get the sum of the infinite series. So this is actually a fairly easy question where I just need to take the limit as n goes to infinity of 3 to the n minus 9 over 3 to the n plus 1. And it turns out that that limit is, the minus 9 is sort of irrelevant, and 3 to the n over 3 to the n plus 1 is going to leave me with just a third. So that is the sum of my infinite series. The harder part of this question is to write an explicit formula for an in terms of n. So we have to figure out what the terms are now, not just the partial sums. So I'm just going to jot this down here. The partial sums are 3 to the n minus 9 over 3 to the n plus 1. Okay, so my first term is also my first partial sum. So I can get the first term by just plugging a 1 in there, and I'm going to get 3 to the first minus 9 over 3 squared is negative 6 over 9, or negative 2 thirds. Okay, so there's my first term, a1. But remember that your second partial sum is the sum of your first two terms. I know the first term is negative 2 thirds. I don't know the second term, but I can get my second partial sum by plugging a 2 into this formula. So that gives me 3 squared is 9 minus 9 is 0 over 27, so I get 0 for my second partial sum, which means that a2 is 2 thirds. All right, so I do a similar thing for finding my third partial sum. S3 is a1 plus a2 plus a3. I can plug a 3 into my expression for the nth partial sum, and I get 3 cubed is 27 minus 9 is 18. A1 is negative 2 thirds. A2 is 2 thirds. And then I'm going to solve for A3. Oh, sorry, I wasn't finished getting S3. My numerator is 18. The denominator is 3 to the 4th, which is 81. All right, and then we solve for A3. Since those two things add to 0, we get A3 is 18 over 81, which reduces to 2 over 9. All right, my fourth partial sum is the sum of my first 4 terms. And I can get the fourth partial sum by plugging 4 into my S sub n formula. 3 to the 4th is 81 minus 9 is 72 over 3 to the 5th, which is, I don't know, $243. Okay, and that equals A1, which was negative 2 thirds, plus A2, which is 2 thirds, plus A3, which is 2 ninths, plus A4. And then we can solve for A4. Just have my calculator do all the work here. So 72 over 243 minus 2 ninths is 2/27. All right, so maybe I'll just do this one more time. I'll get the fifth term, and then hopefully I'll have enough information to write the whole series. Fifth partial sum is a1 plus a2 plus a3 plus a4 plus a5. And a1 was negative 2/3 plus 2/3 plus 2/9 plus 2/27 plus what we don't know. And my fifth partial sum I get by plugging 5 into my partial sum formula. 3 to the fifth is 243. Oops. Minus 9 divided by 3 to the sixth. 26 over 81. So then I just solve for a5. Okay, so I have 2/9 plus 2/27. And then I have to do 26 over 81 minus that. And I get a5 is 2 over 81. All right, so my sum from n equals 1 to infinity of a sub n is negative 2/3 plus 2/3 plus 2/9 plus 2/27 plus 2 over 81. Oops. Plus a bunch more terms that I could figure out if I wanted to, but hopefully I have enough information here. So it looks like all of my terms have a numerator of 2 except for this first one. And my multiplier, except for the first one, I can get from one term to the next by multiplying by 1/3. Which means that this is a convergent geometric series because the multiplier is less than 1. So I'm going to rewrite this as negative 2/3 plus the rest of the terms. And they start with a 2/3, and we multiply by 1/3 over and over again. We'll do 1/3 to the n and let n start at 0. There's the summation notation for that sum. Did I answer the whole question? Yes, I just needed a formula for a sub n. Got it.